everybody. My name is Tish Mendeman, and I am a biology instructor at Eastern Oklahoma State College. The online learning project that I have developed is a Google Doc and using a PhET simulation for students that are freshmen or sophomore in an introductory biology class. This could also be used for those students that are in AP biology. And for this particular assignment, I've chosen to use osmosis and diffusion to help my students delve deeper into those subjects. Most times, students have a hard time with such an abstract concept, with the idea of microscopic particles moving across a barrier. They're also, they have plenty of background knowledge. They can usually tell you what diffusion and osmosis is, but they don't know how they work in practice. Most times students come to me with very little lab experience. They've never seen a microscope. They've never done a wet lab. So this leads to a reticence in those students to perform a lab experiment. So I wanted to do this online simulation to help them with understanding how you run trials, what data you need to record, what data you need to collect, and also to provide them with a inside view of what will be happening in their own diffusion and osmosis experiments in the lab. This particular simulation is from the University of Colorado. They have a website called PhET that they have biology and chemistry and physics and even some math simulations that teachers and instructors can use. They do sometimes come with worksheets. I've made my own to go with this one because there were specific things that I wanted my students to be able to do. So you can see that this is the Google Doc. It has different sections. There's 7 different sections. And for this particular one, they need to follow the step-by-step instructions to make sure that they understand how diffusion and osmosis works. And by the end, by the time they get to the 7th section, they should be able to apply it to a real-life situation. So you click on the following link to open the simulation. I wanted to pair it with a Google Doc because, as you can see from the simulation, there are so many different variables that students can get lost in the minutia of this experiment. So the first thing I told them to do was to select 10 blue particles and open up the data tab. You can see that the average temperature stays the same because the amount of energy inside that one particular section stays the same on average. This is a diffusion of a gas experiment, and that's why the particles are bouncing around and hitting each other, and they're trying to fill up the volume of the box that they're in. So the very first thing that I asked the students to do is to just record their observations about the movement of the particles. So you can see that the blue particles are bouncing off of each other, that the average temperature is staying the same. There's 10 particles. There's no red particles. Their mass is 28 atomic mass units. All of this stuff can be put into their first observation. Once they're done with that part, they move on to the next section. And the next section has them remove the divider and record their observations. So by removing the divider, you have an area of high concentration and an area of low concentration. So when they open up that divider, those particles are going to want to move from a high concentration to a low concentration. And that's what I want them to see. So when they remove the divider, they can see that the particles are now free to move across that barrier. And what they're going to want to do is try and come to an equilibrium, basically. So once you have 5 on both sides, you can see that they have reached an equilibrium and that the average temperature is about the same on both sides. So that's what I want them to record in here. Particles move to fill the space. They're moving from an area of higher concentration to an area of lower concentration. And then the final question really helps them cement the idea that when the particles are evenly distributed, that's when an equilibrium has been reached. And that will guide them in their further sections. So once they answer those questions, they move on to the next section. It tells them how to reset the divider, what next steps to take, what information to record. And I just put in basic gibberish answers so that we could move through this Google Doc together. So they have to do not only one particle, but then they reset the divider and do two separate particles. They also have to change the mass. They also have to change the temperature because temperature affects equilibrium as well. And then number of particles. So if you put more on one side than the other, how does that affect equilibrium? And this final section is where they apply their knowledge. So they use the idea of diffusion to explain osmosis, because osmosis is basically diffusion, but with a semi-permeable membrane, meaning that not all particles can pass across. So they'll already have the information of what osmosis is, but using the diffusion simulation will help them better understand that if this barrier, when we remove the divider, if only blue particles can get through, or if only red particles can get through, what happens then? So they answer the questions, and then they watch this video about how if your cells are performing osmosis because there's more water on the inside than there is on the outside, what happens to that cell? And or if there's more particles on the inside of the cell than there are on the outside of the cell, then water rushes in. So you have to know about this because there's practical applications, and one of them is water toxicity. And this will cement the lesson in an application of osmosis and diffusion in a real world situation. So the ability of these simulations to provide a close-up look into the microscopic world is an invaluable tool for our students. The Google Doc just allows me to very easily collect their information in a format that's easy for me to grade and see if they really know and they really understand the concepts of diffusion and osmosis. So thank you guys for watching this video. I hope it helped, and I hope you see the invaluability of technology in the classroom, but pairing it with the right learning situation and the right learner situation.